Now, I'm going to explain how to work, how to perform with interval distribution series. Here we have a simple example of interval distribution series, the most popular in statistics, the most popular representation of the data, yes, the tabular form of the data. And as you can see, the table is divided into several columns. First column is an ordering column in which we have the number of classes. Yes, each number indicates the number of the class, the number of the interval. As you can see, we have 6 classes, 6 intervals. Of what? Our considered variable is age, yes, which is expressed in years. We have 6 intervals of age. Yeah, if we are going down, if we go down, we increase the values of our attribute. Our intervals has open character. Yes, we have open intervals. They are separated. Minimum value is 0 or O. Maximum value is 70. Okay. And the next information that we have here is frequency. Frequency is the number of statistical units that fall into a particular class. We use symbol Ni when we talk about the frequency, in which I refers to the number of class. So N1 here equals 7. What does it mean? It means that 7 statistical units, 7 people, I guess, are characterized by the age not higher than 17 years old, from 0 up to 17 years old. So the youths, we have 7 young people here. The next value, 12, refers to the second frequency. It means that 12 people are characterized by the age from 18 up to 30 years old, and so on. Yeah? So we know how many people are characterized by following interval of age. How many people? How many statistical units? We can express similar thing, like here, using percentages. We can move to the next column where we have relative frequencies. Relative frequencies, we write the symbol of relative frequency using Fi, in which I refers to the to a specific class. Relative frequency. So relative frequency represents similar thing to similar phenomenon to the in comparison with the previous column, but here we use percentage of statistical units. Yes, the percentage of the class expressed as the decimal, as a decimal, or as expressed by a percent. In first column, in first row, we have Fi, first relative frequency. What does it mean? It means that 4.1% of statistical units are characterized by age from 0 up to 17. Yeah? So we know that 7 people from the entire population represents 4.1% of the entire population. This is simple decimal. How to obtain that amount? We must know the population size. The population size is a consequence of summing the previous column. Yeah? We sum up all the people from all classes. 7 plus 12 plus 45 gives us 171 people. This is the population size. So we know that 7 statistical units of 171 statistical units represents 4.1% of 4.1% of the population. We know also that 12 divided by 171, so 12 people represents 7% of the entire population. Yeah, 12 people or 7% of the population are characterized by age from 18 up to 30 actually, and so on. So here we have the same information, but we see the structure, not the number of the people of the statistical units, but we see only the structure. We don't know how many people we have here, how many statistical units were investigated. We see only the structure of the population. Yes, so here we have a pie. Yes, and we can divide the pie into 6 classes, and we know how many people belongs to the first class, 4.3% of entire pie. In the second class we have 7% of people. In the third one, 26.3% of people. Yeah, in the third interval, so the most numerous, and we have the highest percentage here. So most of the people are in the age from 41 up to 50 years old. Yeah, and here we have 36.3, 18.1 in fifth interval, and the last interval, 6th interval, we have 8.2% of people. Yeah, the oldest. Okay. Now we are dealing with cumulative terms. What does it mean? So here we have the sum of the frequencies or relative frequencies of all classes up to a specific class. It's very simple. I can compare this situation with a snowball. Yeah? For example, here we have first value 7. It answers the question, how many people has no more than 17 years old? The answer is 7. 19 corresponds to the following situation. How many people has no more than 30 years old? How many? 7 plus 12, 19. Yeah? So in this class, our snowball has dimension 7 statistical units. it falls into next class, the second one, yeah? And increase its dimension by 12 people. Now the snowball has dimension 19 people. And in the next step, snowball falls down to the into the third class, and also pull another 45 statistical units. Yes, and now dimension of the snowball is 64. 64 people are characterized by the age not higher than 40. Cumulative terms. How to indicate that we are working with cumulative terms? We put here S letter. Yeah, so it means cumulative. S, it's Polish Polish notation, but we can also see to indicate this is a cumulative value. Yes, but okay, here we have S. Okay, so it can remain NSI. So here we have first cumulative frequency. It is always equal to first frequency. The next column represents cumulative relative frequencies with symbol FSI. We do the same thing as earlier, but we work on the relative frequency column. Yeah. So in the first row, first row answer the question about the percentage of people which are characterized by age not higher than 17 years old. 4.1%. Yeah. The percentage of people which has not more than 30 years old, 11.1. This is a consequence of adding 4.1 plus 7, and so on. Okay, and very interesting feature of cumulative both frequency and relative frequency. The last cumulative frequency is always equal to the population size, and the last cumulative relative frequency is always equals to the sum of relative frequency. The sum of the parts of pi is 100%. Yes, it's obvious. Okay. In the last column we have the middle of a specific ith class. Yes, the middle of the class. It's a very simple category. So it means that we are looking for a value that is placed exactly in the middle between lower and upper bound of the class. So the value that is placed exactly exactly in the middle between 0 and 17 is 8.5. Yeah? How to obtain that value? Lower bound of the class plus higher bound of the class divided by 2. So it's an arithmetic mean between lower and upper bound of the class. Here 24, yes, the distance between 24 and 18 and 24 and 30 is exactly the same. Yes, this is the value 24, here we have 18, here we have 30. This value is placed exactly in the middle between 18 and 30. The best learning is through a practice. So on purpose I didn't read these dry definitions. Yes, I have showed you how to operate by these categories in the table. Yes, in practice. So I encourage you to read this kind of definitions, because we have here formal notation of the properties, features of indicated category in interval series. Like here we have the sum from all the sum of from I equal 1 up to k. K indicates the number of the classes. Yes, as you can see, if we sum up all ni's, yes, we will receive n, the population size. So this operation is to sum up n1 plus n2 plus n3 and so on, and this operation gives us the population size n. Yes, in which and then in each class we can compute relative frequencies by dividing frequency from ith class by the population size, and we will receive relative frequency from ith class. ith class. And of course, the sum of all frequencies gives us 1 or 100%, but we can assume that in our class we will use this kind of decimals with that accuracy, 3 places after a dot. And here we have the definition of the cumulative and frequency and cumulative relative frequency. As I said before, first cumulative terms are always equal to first non-cumulative terms. 7, 4.1%, 4.1%. Yeah, so it is, oh sorry, this is the following situation. Yeah, and next relative categories are the consequence of adding. Yes. Here, for example, 19 is a consequence of adding the previous, the previous cumulative frequency plus actual. So actual means from the same class frequency. 7, the previous cumulative frequency, plus n2. It means frequency from exactly the same class gives us 19 cumulative frequency of the second class. Yeah? So 19 equals to ns2. So it is a consequence of adding ns1, the previous cumulative frequency, plus actual from the same class frequency, N2, yeah, N2. It means 7 plus N2, 12. And this exactly the same thing with cumulative relative frequency. You can practice that. And here we have a formula for the middle of 5 class. Subscript 0 indicates a lower bound of the class. Subscript 1 indicates the upper bound of the class. So here we have x 0, 1, and here we have x 1, 1. So it means that we are dealing with bounds from first class, but here 0 means lower bound of the class and 1 means upper bound of the class. In next class we have x02, x12. Yeah, 30 is x12, 18 is x02. But on the margin it's not very important category, yes? The important thing is to know how to compute the middle of the classes. Okay, we can do the first exercise, the first practical exercise. In one company, the office summarized the job seniority of its workers in interval series, in the interval series. Sorry for the grammar. And we have, as you can see, 6 classes of job seniority, which is our variable. As you can see, the most numerous group are the workers with job seniority from 7 up to 10 years. Yes, job seniority, job experience. And our task is to fill the blanks in the table. Yes, so we'll start with Fi, which is relative frequency. Fi. In order to compute relative frequency, we need what? Fi is Ni divided by N. For each of I equal 1, 2, up to K, because we have K classes, K in our example is 6. Yeah? We need the population size. The population size is the sum from I equal 1 up to 6 from of Ni. Yeah? So we have to sum up that column in order to achieve the population size. So 7 plus 21 plus 35 plus 18 is 112. You can check it out, yes? In order to increase the tempo of our lesson, here I have appropriate computations. Okay, never mind. Relative frequency. First relative frequency, F1. It is a ratio between N1 divided by N. Yeah? So here we divide 7 by 112. Yes, and the result is, maybe we have ensure accuracy 4 places after a dot, yeah, or 3. Okay, 4. We will be more accurate. 4 places after a dot, and we will receive 0.0625. Yeah? this is a consequence of dividing 7 by 112. Here we divide, in that cell, we divide once again, 21 by 112, yeah? And the result is 0.1875. And so on, and so on, and the last value is 9 divided by 112, and we have 0.0804. Yeah? Okay, the command was fill the blanks in the table, so I must be consequent. 1607 01964. Okay, and now we have cumulative frequencies. Yes, NIS. So as you remember, first cumulative frequency is equal to first frequency, 7. In the next step, how to obtain the second cumulative frequency? We have to add first relative frequency and the second frequency. 7 plus 12, 21, 28. Cross adding. 28 plus 35, it's 63. 63 plus 18 is 81. 81 plus 22 is 103, and the last one, the last one is equal to the population size, because it answers the questions. It answers the question: how many people are characterized by job seniority not higher than 30 years old? The answer is every worker. Yes, all the workers, 112 workers. Now we have cumulative relative frequencies, FIS. So the first cumulative relative frequency equals first relative frequency. So we rewrite this value. Yeah. And after that we have what? This value. So the how to obtain this value? We sum previous cumulative relative frequency and actual from the same class relative frequency. This plus this gives us how many? 0.25. 0.25. Sorry, we have here, we can use here a dot, yes, or in Polish notation, mathematical notation habit, we have here this symbol, yeah. Okay, let's go to the next interval. In next interval we add 0.25 plus 0.3125, and the result is 0.5625, and so on, 0.723 to 0.9196. Please check it out, and 1 at the end, yeah, because the sum of all frequencies gives us 1, the whole population. And at the end, cumulative frequency, at the end, the middle of the classes. So, what is the number exactly in the middle between 0 and 2? Of course, 1. Exactly in the middle between 3 and 6. 3 plus 6, 9, divided by 2, 4.5. 4.5. And next values are 8.5, 13, 18, and 25.5. Yeah? And what? At the end we have to interpret following amounts. N3 is how many? 35. And please write the interpretation. It means that 35 people are characterized, or more accurate, 35 workers of a company are characterized by job security from 7 up to 10 years. Yeah? The work experience is about from 7 up to 10 years. Okay. F2, it means the second frequency. Here we have the second relative frequency. The second relative frequency is 0.1875. It also equals 18.75%. What does it mean? It means that almost 19% of people, of workers, are characterized by job seniority from 3 to 6 years. Alright. Next category, fourth cumulative frequency. So we are looking for the column with cumulative frequencies, and we choose fourth value, which is 81. What does it mean? It means that 81 people are characterized by job seniority or has a work experience not higher than 15 years. Yes? Job seniority is for these persons, job seniority doesn't exceed 15 years old. 15 years, sorry. We don't talk about the age of these persons. Okay, and the last one is fifth cumulative frequency. Fifth cumulative frequency is 0.9196. It is almost 92%. Yes, this is an accuracy of that number. The nearest value. What does it mean? It means 92% of workers has a job experience not higher than how many? 20 years. 20 years. And it also means that 8% of people, 8% of workers are characterized by job seniority higher than 20 years old. 20 years, so 20 years. Higher than 20 years. Yeah. And this is all for now. Finally, we have the last task for today. One population have been examined in respect of the obtained income in $1,000 in 2019. Unfortunately, The statisticians drank too much coffee, and lost some of the results. Try to fill the lacks of the gaps of the information in the table. So our task is to recreate the table, the values which are lost in the table, which the gaps are represented by the circles. So let's start with let's start to recreate lower bound of first class and upper bound of last class. What we can see here, the middle of first class is 5. The upper bound of first class is 10. Here we have the middle of first class. Here we'll have upper bound of the class. The question is what value is taken by the lower bound of the class? The answer is very simple, yes? We can denote it by x, so x plus 10 divided by 2 gives us 5. Yes, we multiplied this kind of equation by 2. X plus 10 is equal to 10x equals 0. It's simply 0. The same thing here. We know lower bound of the class and and the middle of the class. So the distance between lower bound of the class and the middle of the class is the same, like here, from the middle of the class up to upper bound of the class. So if distance is the same, so the upper bound of the class is 35. Okay, let's move on to the third column. Here we know that first relative cumulative frequency is equal to first relative frequency. So the values are the same here, 0.08. So it's answered the question, what is the percentage of the people which is characterized by income not higher than $10,000? Okay, in the next step we see that second relative frequency is equal to about 21%. So it is easy to obtain the second cumulative frequency by adding these two values. 0.08 plus 0.207 is, okay, I will use that here, 0.287. This plus this gives us 0.287. How about this value? It's very simple. 0. I'm here. 0.287 plus a known value gives us how many? 0.751. So a known value is 0.751 minus 0.287. Okay, we have almost 7 p.m. so I will use a calculator. 0.751 minus 0.287 and the result is 0.464. Yeah, here we have 0.464. And the last riddle, yes, focus on the last relative cumulative frequency. From the theory we know that this value is always equal to 1, yeah, because 100% of people are characterized by income not higher than $35,000. Yeah, so here this value, double unknown sign, will be a consequence of subtracting 0.751 from 1. Yeah, so the difference between both values are 0.249. Yeah, easy. Yes, it's very easy. Okay, in the middle of the class, of the second class, and the middle of the third class, 11 plus 14 is 25. 25 divided by 2, 12.5. 12.5. And the last one, 24 plus 15 is 39. Yeah, 39 divided by 2 is 19.5. And that's all. I hope you really enjoyed this lesson. Therefore, I have prepared some tasks to you. You can treat this as homework. Yeah, and first task is to expand following operators. The second one is to fill the gaps in the table, so try to compute and ice relative frequencies, cumulative frequencies, relative cumulative frequencies in the middle of the classes on the basis of this example. Try to interpret following categories. Of course, here you have the answers in order to check if you do the exercise well. Yeah, so I encourage you to practice the material in that form. And the third homework is try to build an interval service table using the data. Yeah, here you have individual. If you have here a statistical material, try to assign these values into appropriate intervals and fill the gaps in the column. Here you have also answers. So good luck. If you have any problems, please contact me. You can also leave a message below the film in the comments, so I will try to answer as soon as possible. Thank you.